We've got a couple of things to do today in class, and then I remind you that you have 3 pretty important days coming up here in the next 10 total days. Okay? So this week, Friday, is actual launch day for the Launcher Lab. Okay, so you need to have all of your calculations done, ready to go for that, so that you and your group can launch on Friday of this week. Okay? If you're not going to be here this Friday, you need to set up a time to come in and launch either Monday, Tuesday, or I would extend it out until Wednesday for those people, but no longer, so it's sometime early next week because we need to have those grades in for you. Okay? Then, the Launcher Lab, the completed lab, after you get done launching, the completed lab is due on Tuesday, May 20th. Again, I would extend that out for AP students that are missing this week, Friday, for their AP exam. Okay? On the 21st, which is 1 week from today, on the 21st, you have your last summative test in here and that will include parametrics, all of the things, Ferris wheels, launching, etc. Okay? Love it. All right, let's do this. So we're going to start where we left off yesterday with that Ferris wheel. In one of my classes I got done, in the other class I didn't quite get done. So let's just get done for everyone. Okay? So the 2 equations that we had were 30 cosine of pi over 10 times t and 30 sine of pi over 10 times t, but then we had a plus 40 there. And then we said to ourselves, we got to go at least 20 on the t values. So in the last class, we said we need a number bigger than 20. Oops, they chose 30. Okay. So please, at this point in time, graph that parametrically. You should have that written down in your notes so that we can graph this parametrically at the same time. And then once you get it graphed, then we said that we got to see it, so we needed to change our window. Since we have a radius of 30 on our Ferris wheel, we went out 40s on the x's. Since we have a radius of 30 on the Ferris wheel and we're 10 feet off the ground, that means our Ferris wheel is going to be between 10 as a minimum of the y and 70 as a maximum of the y. So I like to see the ground, so I went 10 to 80 on those. When we graph it, it doesn't look circular. We know it's circular based off of the equation that we have, because our equation says that it is a circle. Just the aspect ratio of our viewing screen doesn't make it circular. if you are one of those that truly need it to be a true circle, we can window zoom and then we can use letter B. You don't have to scroll all the way down. You can just go with B and it will square it up. Then if you grab onto an axis and pull it towards the origin, it will shrink up that circle. Unfortunately, I can't get that to be smaller. Wish I could. Maybe I can put it over here, and then I can slide this over here. And so I like to see the ground. Okay, so there we go. Okay. Then the question that it posed was, what is the position that you're at 22 seconds into the ride? There are two ways to find the position that you're at 22 seconds into the ride. One is you can trace. Okay? And you can make your t value here be 22, provided that your t values in your problem that you set up was bigger than 22. Okay? And so you can scroll to the right and go all the way to 22. I went to 30 so I can. So there's 22. There's my position. Or, because we're going around and we're in the same position every 20 seconds, you could just go right to 2. A t-value of 2 would also give you 22. A t-value of 42 would give you 22, but I can't type in 42 here because I only went up to a t-value of 30. So I would get an error message then in that particular case. Okay? But I could do 2 or 22 here and get the same spot. Okay? So then when looking at it, then we would say to ourselves, self, the position that we're at, we would be 24.271 feet right of center when looking at it, and 57.634 feet above the ground or up on the ride. Okay? We'd have to give them both as separateness. We couldn't give them as a ordered pair there because we want the position. We need to know what it's relative to. Questions, comments, concerns, clarifications? Okay. Some tweaks that can happen then. Okay. So again, just remember that we were talking yesterday about x of t is a cosine of bt plus c, then plus d, and y of t is a sine of bt plus c plus d. Okay? So some tweaks that we can have. First off, if the Ferris wheel is rotating clockwise, I misspoke yesterday and I said that it was the A value. I misspoke. It's the B value that makes it go the opposite direction. Okay? So that's the B value that makes it go the opposite direction. Negate that and you go clockwise. Positive B, counterclockwise. That's it. Okay? If we want to start at the top of the wheel, then our C value would either have to be positive pi over 2 or negative 3 pi over 2. Because we're adding that to our angle. If we want to stat or start without an R, okay, we want to stat or start, on the left side, our C value would be positive or negative pi. And if we want to start at the bottom, our C value would be positive 3 pi over 2 or negative pi over 2. Okay. Or, frankly, we could start at 7 pi over 4, or 5 pi over 3, or 5 pi over 4. I've been on numerous Ferris wheels that have loaded not just in one spot. Your smaller Ferris wheels tend to load in one spot, but your larger Ferris wheels tend to load in multiple spots, because then they don't have to stop it as often, okay, when they can load. That Ferris wheel I was talking to you yesterday about in Cleveland, it loaded in 5 spots. Okay? So there were 5 different gondolas that loaded at the same time. Okay? Alright? With that being said, do number 3 now. Number 3 says the Ferris wheel with a radius of 60 feet, a period of 12 seconds, bottom is 8 feet off the ground. It's rotating in a clockwise direction, and you're starting at the bottom. Give me the parametric equations. Find me the location when you are the position when you're 5 seconds into the ride, and when you're 47 seconds into the ride. And then the final question is, how far have you traveled if you were on the ride for 1 minute? So we should have gotten equations of, whoa, tap the brakes. We should have gotten equations of 60 cosine of negative pi over 6t minus pi over 2. And then we should have had 60 sine of negative pi over 6t minus pi over 2, but then plus 68. Okay? We have a t value of from 0 to 12. That's fine. I'm going to go 0 to 60 because then that gives me 5 revolutions. Okay? So give me a second here to get that one typed in. Oops, not that one. This one. Two, and then, whoops, went too far. And then 60 sine of, do it both ways. Negative pi over 6t minus pi over 2, and then I gotta get up plus 68 there. And then here I want to go 1, 2, 3, and add a 0. Okay? I don't see mine, so I gotta adjust my window, obvi. So I got a 60 degrees on either side, right? Because we got a radius of 60. So I'm going to go negative 70 to 70. I'm going to go by tens. I'm I'm going to go negative 10, and I got to go up at least 128, so I'm going to go up to 140. Now, I'm going to leave this one in terms of, I'm not going to square it up. Okay? I'm just going to leave it as is, just to show you that you don't necessarily have to square it up. We know it's a circle. Okay? So what is the location of the gondola when t equals 5? So we can trace here now on that. We can graph trace. First check is we were told that we needed to go in a clockwise direction, correct? Okay, so we should be going in a clockwise direction, which we are, as we go up to t equals 5. Oh, it doesn't show up at t equals exactly 5. So to make it be actually t equals exactly 5, I can just type in 5, and it takes me right to it. Okay. So then that would give me t equals 5. Now I also have it where I can go all the way to 47, but if you put in a t value that was smaller than 47, you would have to adjust a time frame of 47 seconds back into that first lap of the Ferris wheel. So 47 minus 12 is 35. 35 minus 12 is 23. 23 minus 12 is 11. So you could go to the exact same spot at 11, at 23, at 35, and at 47. And you would be at all of those same spots. And that spot is right there. So at 5 seconds, you're 30 feet left and 119.96 feet up. At t equals 47, you're 30 feet right and 16.038 feet up. Huh? The final question here was, how far have you traveled if you are on the ride for 1 total minute? Okay, well, how many revolutions did you make in that 1 total minute? You made 5 revolutions. 60 seconds, you're going around once every 12 seconds. So that means you went around 5 total times. So that means you went around 5 circumferences of the circle. So therefore you went 600 pi feet, and 600 pi is approximately 1,884.956 feet. or 3.5 of a mile. So 0.35 of a mile. Okay. Questions, comments, concerns, clarifications? Fantastic. Let's shift gears now and let's go to the supplemental sheet that we gave you today when you came into the class. Let's talk about solving this parametric equation without the use of a grapher. Okay? Meaning we're not going to graph it, we're going to solve it algebraically. Yes, we will still need to use the calculator for the calculator part of it, but we are going to be solving this now algebraically because on your launcher lab, you need to solve that algebraically right from the start to figure out where you're going to put the ring of fire, where you're going to put the bottle cap, and what height you need to put it at. So all of this is pertinent to your launcher lab. Okay? Okay? So, an unnamed student was caught playing games on their cell phone during their class, and as a result, their phone was sent hurtling across the room. The phone traveled in a parabolic arc modeled by the given equations. Calculate the following algebraically. So, x equals 88 cosine of 37.5 degrees times t. Y equals negative 16 t squared plus 88 sine of 37.5 degrees times t plus 6. Question number 1 says, how far did the phone travel before it hit the floor and shattered into a million pieces? What do I know about the phone hitting the floor? That the height is 0. So which one is my height function, x or y? Y is the height function. So I need to set y equal to 0 and solve for t. Well, that gives me that in my toolbox, or in your toolbox, what tool do we have to use to solve this quadratic equation? What's the tool that we have? Because it's definitely not factorable because there's a sine or a cosine in it. I'm trying to encourage Caitlin to say it. We got the quadratic formula. Exactly. What is the quadratic formula once again for all of us? It never goes away. It's like a weed in your yard. It just keeps coming back and coming back. So in this case, it would be t equals the opposite of b. Plus or minus. Square root. Big square root. B squared minus 4ac over 2a. All over 2a. Yep. Okay. It's like when you bite your lip once, then you just keep biting your lip over and over and over and over again. Okay? Just keeps coming back. Okay? So my b value is negative of 88 sines of 37.5 degrees. That's my negative b. Plus or minus big square root. Then I've got 88 sines of 37.5 degrees, and I got to square that, minus 4 times negative 16 times 6. Extend that out just a little bit. And then I've got that over 2 times negative 16. Do we agree with that? Now, we have technology. This is the year 2025. We have technology. You are lucky. Let's use this technology. Back in my day, I didn't have technology. I had to do this all by hand. Ay, ay, ay. Okay? Alright? So, I got to get the picture, because I took a picture of it so that I didn't have to keep flipping back and forth. Alright? Here we go. We're going to start ourselves a calculator. Okay? It's a fraction, so I'm going to make it be a fraction. Control divide makes it be a fraction. Negative of 88 sines of 37.5 degrees. Close, close. We can only do one at a time, so we're going to go plus big square root, open parentheses, 88 trig sine 37.5 degrees, close, closed, squared, b squared, minus, open parentheses, 4 times negative 16 times 6, close parentheses, all over 2 times negative 16. Then when you hit enter, you get that. Like it? Not like it? For me.
I thought I did the same answer. You got it?
Yeah. So now go plus. Second. Control. You just got to push it. Okay. Now, again, utilizing technology to make it easy, we don't have to type it in again. We can scroll up and it'll copy and paste the whole thing for us. So all you have to do is go right to there and change that to a subtraction sign. Technology, Miss W. What's up? Okay, give me 1 second. And we get that. So, now, again, on Friday, you need to be exact because we're going to be aiming at something that is smaller. We're going to be aiming at something as smaller than this. Okay? So we need to be pretty much exact, right? So rather than round, because we have technology, I'm going to store that t value in my calculator, and I'm going to let it stay in my calculator. I do that by going Control var. It gives me stow. Okay? I want to stow that in my calculator. What do you want to choose? You got 26 choices that you can choose to store it as. You just got to remember it. I'm going to go with T because that makes it smart to me. Okay? And then when I hit enter, it took this number, this huge number, it took it all and it stored it in as the letter T. So now if I need to use that number, I can just type in T and I don't have to do anything with it. Okay? 3.45 667. Okay? So that's how long the phone was in the air. Now to figure out where that phone landed, now I've got to put that phone, or put that t value in my x equation. 88 cosine of 37.5 degrees times t. So I'm going to replace t with 3.45667. On my calculator, that will look like this. 88 cosine of 37.5 degrees times t. Because I've already got t stored in exact, no rounding. And I get that it landed 241.328 feet away. So that phone was in the air for a while. Okay. Questions 2 and 3 are both cut from the same cloth. So I'm going to do those both at the same time. Okay? Because it's asking how far away was the phone at its maximum height, and then it's asking what was its maximum height. Okay? So thinking back to my previous Algebra 2 days, the x part of the vertex is going to be on a quadratic is at the point negative b divided by 2a. So since my y equation was that, I would need to figure out opposite of b over 2a being negative 88 sines of 37.5 degrees. That's my b divided by 2 times negative 16. And that's going to give me my time, because this is a ty equation, okay, not an xy equation, a ty equation. That's going to give me my time then. So that would be negative 88 sine of 37.5 degrees divided by negative 32. I will just do the 2 times negative 16 in my brain. So that time that it took to get to the vertex, the maximum height, if you will, was 1.67409 seconds. Again, I'm going to store that I can override my last t. Now that I'm done with that t, I'm going to override that t by putting it in there now for t. Okay? 67409. 1. Okay. Now, question number 2 asked how far away it was from, oops, wrong color. Okay. Question number 2 asked how far away it was. Well, that's going to be the x equation. So I'm going to go 88 cosine of 37.5, but now I'm going to multiply that by 1.67409. I'll show you how to rapidly do that here on the calculator momentarily. Question number 3 asked, how high was it? That's going to be negative 16 times 1.67409 squared plus 88 sines of 37.5 degrees times 1.67409, then plus 6. Okay? But because I've got that stored as t on my calculator, I can just type those in as is. 88 cosine of 37.5 degrees times t. So 116.877 feet away, it was at its maximum height. Negative 16 t squared plus 88 sines of 37.5 degrees times t plus 6. It reached a maximum height of 50.8414 feet. So it was 116.877 feet away, and it was 50.841 feet up. Okay. I passed out for you the red homework packet. That is the homework packet that goes along with this unit on launching things and Ferris wheeling things. Okay? Sounds like a great, grand, and wonderful plan.